Solar PV safety and risks. Welcome to our short introduction to the safety and security of solar panels and renewable energy systems. While solar energy is a sustainable and eco-friendly way to harness power from the sun, it's vital to grasp the fundamental aspects of this technology, particularly the distinction between AC and DC current. Understanding these differences is essential for identifying and minimizing the associated risks. Additionally, adhering to specific regulations and specifications is crucial for harnessing clean energy safely. For many years, AC, alternating current, has been the primary source of electricity in our homes, offices, and businesses. Its widespread use is driven by its inherent safety and manageability. However, to better comprehend the risks linked with DC, direct current, we need to explore the concept of the DC arc. DC represents electrical current that flows continuously in a single direction. While there are specialized products designed for DC components, such as switches, fuses, and cabling, the solar industry often lacks the awareness of these essential elements. Moreover, these products, despite their critical role, are frequently not explicitly outlined in quotations, often categorized as consumables. In an effort to keep costs competitive, the quality of these vital DC components is sometimes compromised, and in some cases, unsuitable AC products may be substituted. This substitution can lead to issues, particularly if the installation is not performed correctly or calculated accurately. For example, consider an AC mini circuit breakers that are polarity sensitive. They must be installed in the direction of the current flow and can become instantly ignitable if disconnected under load due to the potential for a DC arc. Several countries worldwide have banned these polarity-sensitive breakers for valid safety reasons. DC breakers, on the other hand, are specifically engineered with an arc-extinguishing chamber and are non-polarity sensitive, meaning they can handle current from any direction and extinguish the arc safely. While DC breakers may be more expensive than AC breakers, their cost is only a fraction of the total PV system expenses. Another significant concern in PV systems relates to hot connections and workmanship, particularly in the context of MC4 connections. While excellent electronics can offer some protection, such as rapid shutdown switches, modular and string types, and emerging technologies like smart optimizers and microinverters, the core risk lies in workmanship and the use of improper tools for crimping these connections, intended to create a reliable cold weld. When MC4 connectors are properly installed using high-quality materials, they function as intended. However, human errors, improper crimps, the use of low-quality connectors, and corrosion can turn these faults into a high-risk potential for arc faults and fires. While some renowned laboratories assess these components for compliance with IEC standards, many of these products only partially meet the requirements. The focus is typically on the connections within the MC4, as they have the potential to compromise the overall safety of the system. There are products on the market that can reduce these risks. Without endorsing a specific brand, these products are additional attachments designed to cover the MC4 connectors. They are made of fire-refractory material to contain any potential arc fires, ideally preventing them from spreading until the system can be safely disconnected or until the arc burns out due to increased distance between the wires. Laboratories often conclude that fewer connections in a PV system equate to lower risk, leaving us with the issue of live wires in what we refer to as the DC danger zone. In the following sections, we will explore solutions that address these risks, enhancing the safety of PV systems for the protection of first responders and users alike. Trained personnel can apply a light blocking coating to solar panels using a pressure vessel or drone delivery method. This coating effectively de-energizes the entire solar PV system, making it safe for first responder operations. The coating should possess additional safety benefits, such as being fire retardant, non-flammable, non-conductive, non-toxic, and environmentally friendly when disposed of. Solar PV panels generate potentially dangerous levels of DC electricity when exposed to light, which is their power source. While solar PV systems include isolation switches and some have arc fault detection equipment, the solar panels and the wiring leading to the first point of isolation remain live when exposed to light, creating the DC danger zone. Fires involving solar panels should not be tackled by untrained personnel, as they pose an electrical hazard. Compromised solar PV systems present a live DC electrical risk, which can escalate into a fire. Solar PV incidents are increasing with the growth of installations, but data collection remains limited due to the lack of defined reporting categories. Whether the solar PV system is the ignition source or indirectly involved, the DC danger zone risks apply to first responders. Solar PV systems integrated into structures alter fire dynamics, affecting flame spread, roof materials, and structural integrity. The challenge for first responders and the insurance industry. First responders need a simple and effective method to de-energize solar PV systems at the source of power production. Without a safe method, fire services adopt a defensive approach to manage risks. We've collaborated with global fire departments, sharing operational best practices and our solution, which was developed in Australia. Early detection and remote monitoring solutions are available but not mandated. Early warning is critical to managing the electrical risk. In conclusion, we are dedicated to enhancing safety in the world of solar PV systems. Our mission is to establish a comprehensive training program for first responders, equipping them with the knowledge and tools to identify and mitigate risks using approved solutions. We aim to guide clients towards safety and create a secure environment for our brave first responders, enabling them to work in safer conditions when addressing potential fires. The safety of first responders is a cornerstone of our efforts, and we firmly believe that by ensuring their well-being, we create a win-win situation for everyone involved. This extends from safeguarding homes, preserving lives, and securing valuable PV systems to minimizing insurance claims and promoting overall safety. Together, we can make a significant impact in ensuring the safety of all stakeholders in the realm of solar PV systems. Thank you for your attention, and we look forward to your participation in our upcoming endeavors.